All right, if you're looking to build a serious enterprise-level network on AWS, you've got to master the backbone. So today, we're going to break down that core architecture piece by piece.
Look, getting a handle on the concepts we're about to cover, this is what really separates a junior cloud practitioner from a senior cloud network engineer. This is the stuff that powers global corporations.
So this is the big question, right? You've got physical data centers, maybe all over the world, and you need to connect them securely, reliably, to your cloud resources that are also spread across multiple AWS regions. How do you even begin to build that global backbone?
Okay, let's start at the very beginning. We'll start with the first on-ramp, the entry point from your private world into the AWS cloud.
This is AWS Direct Connect, or just DX for short. I want you to forget the public internet for a second, because it's unpredictable. This is your very own private, dedicated fiber highway running straight from your data center right into the AWS network. And what does that mean? It means way faster speeds, consistent performance, and a huge boost in security, because your data never even touches the open internet.
But what happens when your company grows? A single highway lane just isn't going to cut it when you're trying to build a global logistics network. You start running into some pretty serious limitations.
And this right here shows the problem perfectly. A basic direct connect is basically tied to a single geographic region. So your connection in, say, Canada can't just talk to your resources over in Europe. It's also been limited historically to connecting to just one virtual private cloud, your little slice of AWS. And most importantly, you can't plug it directly into the modern hub of cloud networking, the transit gateway. This model just doesn't scale.
So, how do we solve this mess? Well, let me introduce you to the first key player in our enterprise architecture, the Direct Connect Gateway. The Direct Connect Gateway, or DXGW, is a total game changer. And the key thing to understand is that it's not a resource that lives in just one region. It is a global resource. Its entire purpose in life is to be a central meeting point for all your Direct Connect lines, allowing them to reach any AWS region you're operating in. And just like that, it solves every single one of the problems we just listed. Suddenly, your 1DX connection in Canada can now reach VPCs in Tokyo and Frankfurt. That single physical connection can now be shared across dozens, even hundreds of VPCs. And, crucially, it acts as that necessary bridge to connect your on-prem network to the transit gateway. You know, this is probably the best way to think about it. Before your on-prem traffic ever gets into the complex world of your cloud VPCs, the DXGW gathers it all up. It aggregates it at a global level. It's kind of like the central sorting office for all traffic coming in from your private data centers.
So now that we have a global entry point, we need to connect it to the heart of our cloud network, and that heart is the transit gateway.
Yeah, if the DXG is the global front door, the transit gateway, or TGW, is the cloud's core router. It lives inside a specific region, and it acts as a central hub that lets all of your VPCs talk to each other and to your on-prem network, without you having to manage all these complex peering connections. It just simplifies everything. Okay, so this is the crucial part. This data path right here, you have to memorize this flow. It is a classic interview question. Traffic starts in your data center. It travels over the physical Direct Connect line. It hits the global Direct Connect gateway, which then routes it to the correct regional transit gateway. And finally, the TGW delivers it to the destination VPC. Got it?
Okay, we've got all the pieces on the board. Now, let's put them together and assemble the final, resilient, enterprise-grade architecture that you would actually see in the real world.
But of course, a single fiber line is a single point of failure. I mean, what if a construction crew accidentally cuts that cable? Is your entire multi-billion-dollar business just offline? No way, it can't be. As the architect, you have to plan for failure. So here's how we build in that redundancy. First, you have at least 2 direct connect lines for physical diversity. Second, you set up a completely separate backup path using a site-to-site VPN over the good old public internet. Both of these are going to connect to your transit gateway. And third, you use BGP. That's the Border Gateway Protocol, how routers talk on the internet, to manage the failover completely automatically. Now, the magic behind this automatic failover is actually a really simple but powerful idea. In BGP, you can set something called local preference. The path with the higher number is always the preferred route. So we just tell our network, hey, the direct connect path has a preference of 200 and the VPN has a preference of 100. As long as that direct connect is up, the network will use it. But the second that path disappears, the only route left is the VPN and traffic fails over instantly. And that is the key trade-off.
You get resilience, but your backup VPN path is going to have less bandwidth and maybe higher costs, which is why DX is always your primary.
All right, let's wrap this up with a quick rapid-fire round of pro tips. Think of these as the key facts you absolutely have to know for any design review or technical interview.
First up, a very common gotcha question. Can you attach a direct connect connection right into a transit gateway? What do you think?
The answer is a hard no. Remember that data path we memorized? The DXGW is the mandatory bridge between your on-prem direct connect and your in-cloud transit gateway. There is no other way to do it.
Okay, next one. You're the architect for a global company. How do you lay out these core components across multiple regions?
The official AWS best practice is this. You deploy a regional hub, that's one transit gateway, in every single AWS region you operate in. Then, you connect all of those regional TGWs back to a single, shared global direct connect gateway. This creates a really clean, scalable hub-and-spoke model for your entire global network.
And that brings us to our final thought. After seeing all these components, the DX, the DXGW, the TGW, the VPN backup, what's the core principle they all serve? Well, the key takeaway is this. Enterprise networking isn't about a single connection. It's about building a flexible, resilient, and global fabric that cleanly separates your physical entry points from your logical cloud core. That is the backbone of a modern AWS enterprise. Thanks for joining this explainer.